So wormholes are a popular feature of science fiction, as they allow interstellar travel within human time, scales the problem with using wormholes to travel in space or times is that they are inherently unstable to stabilize. A wormhole, you need materials that have negative energy density, at least in some reference frame. No classical matter can do this, but it is possible that quantum fluctuations in various fields might be able to. In the Stargate movie and the spin-off television series, the ring-shaped devices known as Stargates can sustain an artificial wormhole for only 38 minutes. It's possible to keep it active for a longer period, but it would take immense amounts of energy. In reality, when a particle enters a wormhole, it creates fluctuations that can cause the structure to collapse in upon itself. A wormhole is a tunnel, if you will, from one location in space to another location space, and it's much like when you want to go from one side of a mountain to the other side of the mountain. You can go all the way up and over, or you can tunnel through, and that will be a shortcut. A wormhole would be a tunnel not through Earth, but through the fabric of space itself. And the remarkable thing is that if you have such a wormhole, we don't know that they exist, but if you had such a wormhole and you're able to manipulate the opening, say, take one opening near the edge of a black hole where the rate at which time elapses that opening will be slowed, then you can transform this wormhole from being a tunnel from one place in the universe to another to be a shortcut from one moment in time to another moment in time. The wormhole can in principle become a time machine. Let me just say again, hypothetical ideas, they come out of the equations. We've never seen a wormhole. If we did have one, we don't know if we'd be able to go through it, but at least the math gives us this as a real possibility theoretically. Black holes could be used to open wormhole portals all across the universe. The current view is that the resulting wormholes are keen to collapse. If you take that two black holes, imagine black hole here, black hole mirror, each of them has a dual description in terms of a quantum mechanical theory on the boundary. If you then entangle those quantum mechanical theories, connect them with those yellow lines of quantum entanglement, it turns out that that's precisely equivalent to connecting the two black holes by, you guessed it, a wormhole. Imagine how we got two black holes, each described by this thermal quantum mechanical theory in the boundary. If we entangle those two quantum mechanical theories, there are these yellow lines at quantum entanglement that's equivalent to joining the two black holes by an Einstein-Rosen bridge, a wormhole. The idea that wormholes might exist has been around for a long time. Wormholes, or Einstein-Rosen bridges, are hypothetical tunnels through space-time that were predicted by Albert Einstein's theory of relativity. They can connect two separate regions of space as well as different points in time. Although Einstein's general relativity theory allows wormholes to exist, it is believed that they are unstable because, in essence, they consist of two black holes touching each other. If you are the object falling into the black hole, then you will, at least in the traditional way of thinking about black holes, you will fall in. You will make it to the event horizon, and in short order, depending on the mass of the black hole, the size of the black hole, you will find yourself increasingly uncomfortable as you get ever closer to the central singularity. You will fall in if, however, someone is watching you at a safe distance heading toward the black hole. Their perspective on what happens will be different. And this has largely to do with this weird property of black holes. Time slows down near the edge of a black hole. Time slows down. The basic idea is that gravity doesn't just pull on matter. It doesn't just pull on energy. Gravity, in a sense, pulls on time itself, or even more precisely, gravity is the warping of time. Gravity is manifested by the fact that clocks at different distances from a gravitational source will take off time at different rates. The idea is based on general relativity, which predicts how space and time warp in various ways under certain conditions. According to that theory, there are discrete parts of the universe where space and time are independent of one another. The impossibility of faster than light relative speed only applies locally. Wormholes might allow faster than light travel by ensuring that the speed of light is not exceeded locally at any time while traveling through a wormhole. Slower than light speeds are used if two points are connected by a wormhole whose length is shorter than the distance between them outside the wormhole. The time taken to traverse it could be less than the time it would take a light beam to make the journey if it took a path through the space outside the wormhole. However, a light beam traveling through the same wormhole would beat the traveler. Scientists have spent decades studying the possibility of space travel through wormholes, a hypothetical solution of Einstein's general theory of relativity, But even though wormholes can be mathematically proven to exist there, instability remains a significant problem. There might also be a link between wormholes and quantum entanglement. Entangled particles inside and outside of a black hole's event horizon are connected via wormholes. I've taken space and folded it over so that this region over here is close to that region on the diagram. These two places are very far apart. The new thing, because they're entangled, is that an Einstein-Rosen bridge fault forms between them. An Einstein-Rosen bridge is popularly called a wormhole. It's a route through space which short-circuits the long distance between these. This is, up to my mind, one of the craziest things we've discovered in the last 20 years, that the existence of entanglement creates spatial connectivity between two regions which would otherwise be very, very far apart. A new theory by physicist Pascal Coiron proposes that these cosmic bridges might be more stable than previously thought. If the theory that contradicts earlier predictions turns out to be correct, and wormholes can be made stable, wormholes could be used to pass through the void between galaxies. Without the need for faster-than-light travel, they would in principle allow travel in time as well as in space. If a particle can traverse a wormhole safely, humans may be able to take a spacecraft through and reach a distant planet in a galaxy far, far away. Before this new theory, it was widely believed that a form of theoretical exotic matter would be needed to keep a wormhole open, as it would disappear quickly after its creation without a force to prevent it from closing. Einstein and Rosen constructed their wormhole with the usual Schwarzschild metric, and most analysis of wormholes use that same metric. So physicist Pascal Coiron tried something else, using the Eddington-Frankenstein metric instead. This allowed him to trace the path of a particle through a hypothetical wormhole more easily. He found that the particle can cross the event horizon, enter the wormhole tunnel, and escape through the other side, all in an infinite amount of time. The Eddington-Finkelstein metric didn't misbehave at any point in that trajectory. But according to astrophysicist Paul Sutter, general relativity only tells us about the behavior of gravity and not the other forces of nature. However, according to Sutter, Coiron's result is still interesting because it points out that wormholes aren't quite as catastrophic as they first appeared, and that there may be stable paths through wormhole tunnels, perfectly allowed by general relativity. Perhaps someday humans might be able to travel through a wormhole to visit other parts of the universe. Whether wormholes are really possible or are just a part of science fiction remains to be seen. The only thing certain at this time is that scientists are working hard to find out more about them. In the meantime, we can only watch movies like Stargate to experience the world of wormholes. Thanks for watching. Did you like this video? Then show your support by subscribing and ringing the bell to never miss videos like this. Music you.